of the figure. So the triangle is equilateral triangle, and if we are constructing a segment here, altitude, we already know is going here to bisect this triangle is going to be 30, 90, and 60 degrees. So each triangle is 30, 60, 90 degrees. And if the hypotenuse is at 12, we already know this one is going to be 6. And the hypotenuse here is going to be 6 times square root of 3. 6 times square root of 3. And the center of the circle is going to be the same center for the equilateral triangle. And we already know the radius here is going to be 1/3 of the altitude of the triangle and times 6 square root of 3. So for the big circle, so let me write here a big circle. So for the big circle, the radius is, when we simplify, is a 2 times square root of 3. Okay, so let me write here a little bit. So then, if we are looking to find the square here, the sides of the square, we already, if we are constructing one diagonal from this side to this side here, we already see this is going to be, it divides, each angle is 90 degree, and the diagonal dissects the 90 degree in 45, 45, 45, 90 degree. And we already know this is a 45, 45, 90 degree. We already know the hypotenuse here, a square root of 2, is going to be equal with the diameter of the circle. Diameter of the circle is 4 times square root of 3. When radius is 2 times square root of 3, the diameter is 4 times square root of 3. When we are simplifying a, so one side of the square is going to be equal with 2 times square root of 6. When we are simplifying, 2 times square root of 6. So this is one side of the big square. And now if we are looking to find the small circle, we already know we can write here, for example, here is a 2/3, and if we are making one a small triangle here, in this small triangle we already see this altitude is a 2/3. If we are going with the same principle to find the center here, is going to be 1/3 of the altitude of small triangle, which is a 2/3. So this one here is a 2/3. Okay, and now the smaller circle, so the radius is going to be 1/3 time 1/3 times 2 square root of 3. So this is going to be the radius of the small circle. But if we are looking now at the square, we are going with the same principle what we did here. And we already know if we are constructing diagonal here, is going to divide this square into special triangle 45, 45, 90 degree. And the diagonal of the small circle is going 2 times the radius. And 2 times the radius of the small circle is 4 square root of 3 divided by 3. And now I'm looking here what I can find now the A, one side of the small square. To find one side of the small square, I'm going here A, let me say A1 to be a little bit different from A here. Square root of 2, A is going to be equal with 4 times square root of 3 divided by 2. And this implies, when we are simplifying everything, A1 is equal with 2 times square root of 6, 2 times square root of 6, and is divided by 3. Okay, and now what do we have here? To find now the shaded area of the triangle is, so area of the shaded area is going to be equal with the area of the big circle plus area 3. We have three small circles. Area of the three small circles is minus area of the square of the big square, and is minus 3 area of the small square. And we are substituting everything. A shaded is equal with a pi times r square, and r was 2 times square root of 3 square. Here is a plus 3 times pi, and this radius of the small square is equal 1/3 to square root of 3. So let me write here 2 times the square root of 3 divided by 3 square is a minus. Now we are taking the area of the square, the big square. So area of the big square, one side was 2 times square root of 6. Everything is square, minus 3 times, we have 3 small squares, 3 times 2 square root of 6 divided by 3. And now where we are simplifying here, a shaded area of the shaded circle, shaded figure is going to be 12 pi plus 4 pi. I forgot here to write pi, and is a minus 24 minus 8. And if we are simplifying further, is a 16 pi minus a 32. Or to write in a better form, I would write this way. Shaded area of the figure is equal with a 16 pi minus 2 units square.